I'm Anil Kumar. Here is another question from previous test paper on quadratic functions. We'll now discuss question number 11. Here is a copy of this question. A projectile is launched off the top of a platform. The table gives the height of the projectile at different times during the flight. So that's the table we're talking about. Determine the equation in standard form that models these data points. So what we are given here, with respect to time, we are given height. Time is in seconds, height is in meters, 0, 1, 2, 3 seconds after the projectile is launched. The height is 11, 36, 51, and 56. We need to find the equation of this projectile in standard form. You can actually pause the video, answer the question, and then look into my suggestions. Now, one thing is very clear, that this is a projectile motion. Therefore, second difference should be constant, correct? So the idea is we will find finite difference. So I'm writing delta for difference. So finite differences, you do 36 minus 11, write down what you get, right? So we'll do for each. So we'll do 51 minus 36, 56 minus 51. And that will be our first finite difference, right? So 36 minus 11 is 5, and 3 minus 1 is 2, 25. 51 minus 36, 11 take away 6 is 5, 4 take away 3 is 1. This 15 should have come here, and 56 minus 51 is 5. Clearly, the first difference is not constant, right? So first finite difference is not constant. Let us now find the second finite difference, right? So we'll again find the finite difference. This time it will be 15 take away 25, 5 take away 15. So that gives us 15 take away 25 is minus 10, 5 take away 15 is minus 10. So this is constant, right? So we get second difference as constant, right? Which is minus 10. Therefore, it is a quadratic function, correct? Now, when we say writing equation standard form, what are we saying? We want to write the equation, let me write down the equation here, as y equals to ax square plus bx plus c. Is that okay? So that is how the equation should be. Now, in our case, y is the height in meters and x, the variable, is time in seconds. So what I will do here is I will use the variable h with t for height, t for time in seconds. So we'll write our quadratic equation in terms of these variables. So I'll write my equation as h of t equals to at square plus bt plus c, correct? So it becomes height in meters and independent variable is time t in seconds. Now, if the second finite difference is constant, then can you tell me what is the value of a? Well, as you know, finite difference really tells you what the value of a is. And if the second is constant, then it is constant finite difference divided by 2. So we know that a is equals to minus 10 over 2, and that is minus 5. So that's the value of a. So the formula which I have used here is that if second finite difference is constant, then a equals to that constant finite difference, which is the second one, divided by 2. Okay. In general, the formula for any polynomial will be, the general formula will be that finite difference, if it is nth is constant, divided by n factorial. We'll talk about it later. Anyway, at present, this is good to use, right? So we know the value of a is minus 5. Another thing which you know directly from here is that if I substitute 0 for time, then the height is 11. So if I substitute 0 here for t, these two terms will be 0, c will be 11. Do you see that? So since we know that at 0 the height is 11, correct? So if I substitute 0 here, what do I get? So that means h of 0 equals to 11, right? So if I substitute 0 here, I get a times 0 plus b times 0 plus c, and that gives us the value of c as equal to 11. You get the idea, right? So I'm using slightly different method to find the equation, but this is a very efficient way of doing it, right? Okay, so we got two variables. So let me write down the equation first with these two values. So h of t is minus 5t squared. B we don't know, so we'll write bt. C is 11 plus 11. Now we have only one variable to find. We can use any one of these given values. Let us use 1 and 36, correct? So now we'll use the point 1. After 1 second, the height is 36 meters. That is what we'll use. So if I use this, what do I get? So for 1, the height is 36. So we can write 36 is equal to minus 5 times 1 square plus b times 1 plus 11, right? Solving, we can say 36 bringing minus 5 to the right is plus 5, bringing 11 to the left, is 11 minus equals to b, right? So this value is 36 plus 5 is 41. 41 minus 11 will be 30, right? So we have 30 as the value of b. You get it, right? So once you do this calculation, we get b as this. We already have c and a. So now we can write down our equation, which is h of t is equal to minus 5t squared. B is 30 plus 30t plus 11, right? So that is the answer. So that is how you can very effectively or easily solve these kinds of questions. Well, the standard alternate method is, in this given equation, we should use 3 set of points. So we could use these points. Let me just highlight these points. We could use this set of point, this set of point, and this set of point. So we'll get 3 different equations. Solving these equations one by one or simultaneously, as you say, we'll get the value of a, b, and c, and that is how you could actually get the equation, right? But I hope you understand this method. I have many other examples where we've done this standard way. So look into this. Important things to remember is that if second difference is constant, it is a quadratic equation, and it also relates with the leading coefficient a. So value of a is second difference divided by 2 for a quadratic equation, right? So we got this. That is easy to understand. Initial value is always c, right? So you get c and b, c and a. To find b, use any other point, solve, and get b. I'm Anil Kumar, and I hope this solution helps you to understand the concept better. You can always share and subscribe my videos. Thank you, and all the best.